You're starting to get familiar with solving problems in your thermodynamics class. You might be thinking, wait a minute, I've already taken a class or I'm taking a class in MATLAB, and that's a problem-solving technique, problem-solving tool using the computer. And you might be thinking, wow, I might want to try dabbling in solving some thermo problems in the MATLAB environment. So I want to just give you some ideas on how I might go about solving homework problems using MATLAB associated with thermo problems. So let's get started with a little example problem. I hope that you've seen my video on solving problem 223 on the YouTube channel. And so what I like to do, and so that's something you should see first because that's going to help you prepare for quizzes and tests. And that's really the key of your getting a good grade in this class, in addition to learning the material, is performing well on quizzes and tests. So that's really a key, but this might be a little extra if you want to dabble in how might I solve a problem using MATLAB that either I'm working on right now or I've already covered in a previous class. So let's look at how I solved problem 223 using MATLAB. Okay, and so here's the problem as a refresher. It's a gas contained in a piston and cylinder, closed system. It undergoes three processes in series, a constant volume process, 1 to 2, a compression process where the path is PV equals constant from 2 to 3. Hopefully you've got that in your head. And then process 3 to 4, constant pressure process to a final state, state 4. And so consider how might you solve this relatively easy, let's say maybe moderate problem in the MATLAB environment. But the point is, you're still going to have to start with a sketch. You can't do everything in MATLAB with these thermo problems. You're going to have to start with pencil and paper with a sketch first. Okay, let's dissect solving this thermal problem from scratch. Okay, gas contained in a piston cylinder. So that key word that says it's a closed system. Talks about three processes. So we're going from state 1 to 2, that's process 1, 2 to 3, that's the second process, and then 3 to 4, that's the third process. So we're changing our states from 1 to 2 to 3 to 4. And let's see, what are you asked to do in this problem? It says, well, 1, sketch the processes on a PV diagram. You're going to have to do that with pencil and paper, but then finally, evaluate the work for each process in kilojoules. That's going to be very easy to do in MATLAB once you've got that sketch. Okay, so we're going to start by planning our work. Process 1 to 2, constant volume process. That's the process path, constant volume. What would that look like on the PV diagram? Process 2 to 3 says PV equals constant. That's the process path. What would it look like on a PV diagram? And then process 3 to 4 is a constant pressure process. What would that path look like on a PV diagram? Okay, so we're going to move on. And so in the pencil and paper solution, I sort of drug out this laboriously, but we'll quickly say, here's what the sketch is going to look like. Process 1 to 2, constant volume, it's a vertical line. 2 to 3, that's a hyperbola because what's given in the problem statement, it says PV equals constant. And so if you do the algebra, you'll see that P equals constant divided by V. That's an expression for an hyperbola. You're going to find the work for that. And then 3 to 4, a constant pressure process. That's a horizontal line, 3 to 4. How will we go about getting the work done for each one of these processes? We're going to basically use the work as the integral of PdV. That's a fundamental. That's not a formula. That's a fundamental for a closed system undergoing a quasi-equilibrium, or in other words, process path defined process. and that's the way we're going to get our results. So once you have the sketch, it's easy to visualize the workout for each process. And we're going to numerically evaluate each in MATLAB. Now, how about 1 to 2? What's the work from 1 to 2? That one's easy. That visually, you see that the work from 1 to 2 is 0. 2 to 3, let's see the integral. We're integrating from right to left. And so whether you know a lot about MATLAB or not, you've got to know that when you're integrating from right to left, you're going to get a negative value. And then 3 to 4, same idea. You're integrating right to left, you're going to get a negative value for the work. So we're going to evaluate integral PDV for each process to get our values. And that's my signal to go live. So I'm going to switch. And so what I want to do is show you how did I solve this problem numerically in MATLAB. So this is my key to go live. Let's see if I can do this, pull this off. I'm going to hit escape and I'm going to go to the MATLAB environment. And I have loaded problem 2x23.m into my working window here. And so let's just kind of look and see how did I solve this? So I've got my sketch on pencil and paper. The first line is a comment. I tell you what problem it is. Here's my initials and when I worked on this problem, May 22nd. Okay. I tried in comments, these little percent signs. In comments, I tried as best I could to quickly summarize what is the question I'm trying to solve. Okay. Determine the work done for each process. In comments, I'm trying to describe what's my approach? What am I going to do? I'm writing out closed system. I'm summarizing the work out 1 to 2, 2 to 3, 3 to 4 in comments. Okay. And let's see, it says use 2 to 3 process path to find P3. So I did enough planning in my head to summarize what I'm going to do in MATLAB. So let's scroll down a little bit. Here I'm saying, okay, here's my solution. Here's my tried and true clearing of all my stuff. I just sort of learned that by picking up the work of others that I saw working. Next thing I do is define all the given and known information. So you can see what I'm doing here is I'm writing out V1 equals 4, but see here in comments, so I'm that semicolon suppresses the command window kind of extraneous stuff. So I'm suppressing the command window output until I'm ready for it. But in comments, V1 is equal to 4. I'm putting units. V2 equals V1. That's given in the problem statement. V3 is 2 cubic meters. V4 is 1 cubic meters. Okay. P1 is 100 kPa. So in my world, I just immediately changed bars to kPa because I know I've got to keep my units straight and to get kilojoules of work, I've got to be working in kPa, kilonewtons per square meter. But I'm always writing my units out. And then also I'm writing W12, the work from 1 to 2 is 0 because there's no work done. We've already observed that from our sketch. I'm going to scroll down. Now I'm thinking about solving the problem and preparing my command windows. Well, I'm actually preparing a title for my command window, display result for problem 223. Okay. The next thing I did was determine the constant for the process, P2, V2, because P2 and V2 were given. So I'm just going to have a variable named constant. Variable name is constant equals P2, V2. And I'm writing out the units are shown. You can derive kilojoules. The next thing I did was determine, well, what's P3? Because I know I'm going to need P3 in my solution. So I know that P3, V3 is constant. So I'll solve for P3 is constant over V3. I just found my constant, so I can solve for P3. There it is. Okay. Now I'm going to go about determining the work for process 2 to 3. 1 to 2 already wrote down was 0. 2 to 3. The work from 2 to 3 is the integral of PDV. So from my pencil and paper work, I've got the integral of the constant over v dv, and I can just do this by hand, right? Is the integral of constant over v dv is the constant times the natural log of v3 over v2. And now, all that was just a comment, but now in MATLAB, I can create my code W23, that's my variable name, equals constant, already determined, times in MATLAB, it's log, that's the natural log in MATLAB, log. It's a little strange, but I had to learn more about that with the help function, log of v3 over v2, not ln, log of v3 over v2. Okay, the work for process 3 to 4, that one was easy. Constant pressure process. In my little comment, I wrote W34 is integral PDV. So for a constant pressure process, I've got P3 times V4 minus V3. I've already entered all my numbers here. And so I've got variable named W34, the work from 3 to 4, is P3 times V4 minus V3. And I've got my units of kilojoules. And so finally, I've been suppressing all my command window outputs. So now I'm ready to summarize. I'm just going to say result is W out from 1 to 2 equals, and then I'm going to change the number W from 1 to 2 to a string. Same thing for work out 2 to 3. Change W23 from a number to a string, num to string. That's the MATLAB code for change your numerical number into a string or text value. And then finally the result for W34, and I'm just displaying them sequentially. And that's it. So let's see if it works. I'm going to click the run icon. And boom, it ran, thank goodness. Now, I might have had to do some troubleshooting from here or there if something blew up on me, but it worked. And so in my command window output, I've got result for problem 223 with some underlines. Work out 0 from 1 to 2. Work out 2 to 3 is negative 554.5 kilojoules. Work out from 3 to 4 is negative 400. And that's it. Simple as that. And so that is my MATLAB solution for a pretty easy thermo problem. So let's go back to PowerPoint and recap. Okay, so the first part of my MATLAB block was nothing but comments, starting with the percent signs, problem statement, and how I would approach the problem. The next part was, after clearing, I defined all my given information sort of in one block. Then I went through and I checked my sketch and any handwritten notes I had to create the code, very simple MATLAB code to do all the computations. I prepared my command window output so that my command window output would be pretty. And so there would be my command window output. And so if I wanted to turn this in, well, let's see. There's some advantages and disadvantages of creating thermo problem solutions in MATLAB. Now, so let's do some disadvantages first. Disadvantages. It's awkward because you don't end up with a single document. You end up with sort of different types, different documents to turn in. So that makes it a little tougher. You got to start with a sketch. So you're going to have some type of screenshot or a pencil and paper thing to turn in that's your sketch and pre-work. Then you're going to turn in your MATLAB code, and you'll also turn in your command window output. And so you do see that simply turning in command window output, you're probably not going to get a whole lot of credit simply for turning in command window output, pretending like that's a full engineering solution. So awkward for single document solution. And also the work that you go through to prepare a MATLAB solution is a little different, a lot different than preparing for a quiz and test. So you know that in quizzes and tests, you're going to definitely be doing pencil and paper work with a calculator. Don't know what your setup is specifically with using your PC, but certainly you're going to be creating sketches with pencil and paper. So that's a little bit of a disadvantage. An advantage of a MATLAB solution, it forces you to be disciplined in terms of your mathematics. You've got to work down the page in terms of your math. You can't work all over the page. If you have repetitive assignments, and you may find that many of your assignments in Thermo are going to be repetitive, it can speed the solution time when you're doing repetitive things over and over again, because you can save as MATLAB work to a different file name where it's repetitive. And also it gives you a template for solutions to repetitive work. And so that was a key for me when I would practice engineering. In my work situation, I had very repetitive situations, not exactly the same, but similar situations where I could go back to MATLAB solutions, or let's say Excel solutions, and use save as to really leverage work that I had done in the past. And so there's advantages and disadvantages to using MATLAB in solving thermal fluids heat transfer problems. So just as a recap, thermal systems problems, you're always going to be starting with a sketch. You're going to plan your work before you start calculations. Once you've done those two things, you can implement your computational work. In MATLAB, you do want to include units as you go along. I wanted to demonstrate how to use comments in MATLAB to get your units coming through with your numerical work. And then you're going to be printing your numerical results along with units in the command window. So I hope that gave you maybe some ideas on how you might combine your mechanical engineering classes. You've already done MATLAB, or you're doing it now. And so you can think about as these thermo problems get harder and harder, some of you might think about how might I use MATLAB to leverage my work and maybe save some time. So hope that helps, and consider integrating your MATLAB work with thermal systems problem solving.